Thank you for the opportunity to present here today from the southern tip of Africa. I'm talking about how migrant waders have changed their ranges over the past 3 decades between the first and the second bird atlas projects. I'll start with some resident waders. What you see here is a mixture of colors in each of the grid cells. Red means decreases, blue means increases, and we see here all the shades that are used in these maps. But in this map for the Palearctic migrants, the overwhelming color is red. 12 migrant waders, all alarmingly red in color. So the big picture of this talk is that the resident waders are doing reasonably well. And this is evidenced by multicolored maps like the one for the African oystercatcher, which is expanding its range in the Eastern Cape and KwaZulu-Natal. But this map of the common sandpiper is typical of Palearctic migrants. They're showing largely red, which means big decreases. So these maps are based on reporting rates between the first and the second bird atlas projects in Southern Africa. SABAP 1, bulk of data collection, late 1980s, early 90s. SABAP 2 started in 2007 and is still ongoing. Protocols differ between the projects, subtle differences. So a cautious approach is needed to the statistical analysis. In fact, data analysis. There's no p-values in this presentation. So we do field work throughout the year. We use a grid based on latitude and longitude. SABAP 1, a 15-minute grid. SABAP 2, 5-minute grid. So there's quarter-degree grid cells and pentads. And we ask the citizen scientists to go out and collect species lists for each of the grid cells. For SABAP 1, the fieldwork protocol was just simply to produce a list of birds from somewhere inside the quarter-degree grid cell. 7.3 million records were collected, the largest biodiversity project in Africa at the time. SABAP 2, minimum fieldwork period, 2 hours, and we persuade people to make as comprehensive a list as possible and to try and visit all the habitats within the grid cell. So 16.1 million records collected so far. And amazingly, the number of species per checklist between the 2 projects is much of a muchness. So we make no attempt to correct for effort. And for this analysis, we lumped the pentads together, the 9 pentads that make a quarter-degree grid cell, and analyzed it on the SABAP 1 system. So let R be the reporting rate of a species, the number of times it was reported, divided by the number of checklists for the grid cell. Lies between 0 and 1. And 1 minus R is the proportion of checklists which don't have the species recorded. So it's a measure of absence, and we need that on the next slide. So R is what interests the bird watcher. It tells you the likelihood of seeing the species. But for the scientist, it's problematic because reporting rate depends on 2 things: the number of birds of that species in the grid cell and how conspicuous they are, whether they are loud callers or reedbed skulkers. So let there be n birds of the species in the grid cell, and the detection probability for that species is p, and then we can calculate the probability that the citizen scientists misses all n of the birds completely. So 1 minus p is the probability that misses 1, and if he misses them all, 1 minus p to the power of n. So that's 1 minus the reporting rate, missing the species completely. So we have that equation, 1 minus r equals 1 minus p to the power of n, and we solve it for n quite easily. And we have that formula for the first and the second bird atlas projects, and we can take N1 and N2, compute their ratio. N2 divided by N1, the amount the species has increased or decreased between the two projects. And the detection probability terms cancel, and we end up with that remarkably simple estimate of the relative change in abundance at the bottom of the page. So now we have to add color to the map. We compute the relative change for every grid cell for a species, and we used those cut points to determine the shades on the map. So red is equivalent to an estimate that the SABAP2 population for the grid cell is 1/3 of the SABAP1 population, and blue means a 3-fold increase. So we summarized the map by counting. There are 1,717 grid cells for the blacksmith lapwing, 384 red, 366 orange, and some other numbers for the other colors. And we are focusing on decreases. So we looked at the reds and the orange and divided by the total number of grid cells, and we get 44% of the grid cells are showing large or moderate decreases. We do this for all 17 species, 5 migrants, 5 residents, 12 migrants, and we get a table that looks like this. And now I'm focusing on the red and the orange, and 30% of grid cells for the oyster catcher show a large or moderate decrease. But if you take the medians for the residents, it's 43% of the grid cells are showing decreases. For the migrants, it's 60% are showing decreases. So the migrants are faring worse than the residents. Don't need statistics to tell us that. So here's the map for the common sandpiper, which has 73% of the grid cells as red or as orange. The median of the C values for this species is 0.49. So as a ballpark first estimate, we reckon that we've lost half of our common sandpipers in the past 3 decades. This version of the map has the 2 reporting rates and the C values inserted into each grid cell, but at this scale, all you see is little black smudges. So I need to pick a piece to enlarge. I picked that piece. And there's common sandpiper reporting rates at the top for SABAP1, in the middle for SABAP2, and the calculation of C, the relative change, at the bottom. And if you search through the map, you see some quite alarming decreases. So my final points is that Atlas projects like this are designed to give us big brush pictures of changes in distribution and relative abundance. They're not the end point of the analysis. And they provide the early warnings of change across all species, not just the waders. So they need to be followed up with targeted initiatives. What do I think is happening? In ballpark terms, first-year waders migrate only as far south as they need to go to find a space. So as waders decrease, the ends of the migration routes are more likely to be the places where changes are first observed and where these changes are likely to be exaggerated. So the Atlas projects in Southern Africa are really, really important from this migration perspective. Finally, I'd like to thank the thousands of citizen scientists, both SABAP 1, SABAP 2, who've made this presentation possible. Michael Brooks wrote the query that produces these maps and tables. This technology that makes it possible for me to sit in Cape Town and talk to you is pretty remarkable. And I'd like to thank all of you for being here today to be part of this presentation. And I am happy now to try to take any questions which you have regarding this presentation. Thank you.